Good day! So, tuloy tayo sa functions but this time we'll review kung paano natin ina-apply yung geometric transformation sa functions. So, this is mostly a review. No? Nakita na natin to nung pinag-uusapan natin yung translations tsaka reflections at in-apply natin siya sa functions. So, balikan lang natin mabilis. So, yung gusto nating babalikan ngayon ay una, review natin yung vertical and horizontal translations ng functions sa Cartesian plane. Tapos pangalawa, review ulit natin paano mag-reflect along the y-axis and along the x-axis. And I think maybe something a bit new, we'll demonstrate simple scaling sa functions, like we'll scale it by a factor of k. So let's say we have a function f of x. Now, pag minodify natin siya, no, na yung x, papalitan natin ng x minus h, tapos nag-add tayo ng k dun sa labas, we are combining two translations. Recall, yung x minus h, this will translate our function h units to the right. So kung negative yung h, magiging x plus something, mag-move siya effectively to the left. So we could still say no, na nag-move siya h units to the right. And pag nag-add tayo ng k, mag-move siya ng k units upwards. Again, no, if k is negative, so negative k units upwards, it's a net movement ng downwards. So combining those two, we are translating the function by the vector hk. So here in this example, I have f of x equals x squared. So ito yung parabola na naka-vertex sa origin. Pag in-apply natin yung f of x minus 3 minus 2, effectively, this will move the vertex from the origin to 3, negative 2. So magkakaroon tayo ng translation ng vertex by the vector 3, negative 2. At hindi lang yung vertex, lahat ng points dun sa function matatranslate to its corresponding point dun sa image nung translation. And this should be familiar kasi ginagawa na natin siya before. So here, balikan naman natin yung pag-reflect ng functions along the x and the y axes. Start tayo with the x-axis. So given our original function f of x, if we construct a new function, this time, tatawagin natin f sub y equals 0. Recall, y equals 0 is the x-axis. Na equal siya sa negation lang ng original function natin. Effectively, this applies a mirror reflection transformation dun sa original function about the x-axis. It makes sense kasi lahat nung y-coordinates nung original green function natin ay i-flip lang niya along the x-axis para maging negative kung positive siya, positive kung negative siya. So effectively, it's a mirror reflection transformation. So in this example, my original function is x minus 3 quantity squared minus 2 para may vertex tayo sa 3, negative 2. Pag in-apply natin yung transformation na yun, yung new function equals negative f of x, and then we'll see dun sa red function na it's just a reflection along the x-axis. Now, sa y-axis naman. So again, we have an original function, f of x. If I create a new function, tatawagin kong f sub x equals 0 para lang alam natin na sa y-axis siya. Na equal lang siya sa negation naman nung variable. So instead of negative f of negative x, we are replacing x with negative x. This will apply a mirror reflection transformation na finiflip niya or nire-reflect niya yung function about the y-axis. So here I have a original function f of x. It's x minus 3 squared minus 2. Again, naka-vertex sa 3, negative 2. Pag gumawa tayo ng bagong function na inenegate lang natin yung x, you'll see sa red function, it's just a reflection of the green function along the y-axis. So again, we encountered this before nung nagdi-discuss tayo ng functions and transformations. So this should not be anything new for us today. So let's go to something na medyo bago. That would be scaling naman ng functions. How do we apply a scaling on the graph of a function on the Cartesian plane? Okay, so let's say we have a function f of x, our original function. Here, it's the green one. It's the square root of 9 minus the quantity x minus 2 squared. It is a semicircle na nakacenter sa 2, 0 at ang radius ay square root of 9 or 3. So it's this green circle. Now, pag gumawa ako ng bagong function, we call it f sub k of x, although you can use any name naman, no? Na equal lang siya ta some constant k na nakamultiply sa original function natin, then this will apply a vertical scaling to f of x by a factor of k. Imagine natin, lahat ng y coordinates, ng lahat ng points dun sa green semicircle natin, mata times k. So in this example, ang k na ginamit ko ay 3. And let's see what happens. See, I have a point here, 2, 3. It's the highest point of my semicircle. Pag in-apply natin yung scaling function, times 3 dun sa original function, and then that's essentially multiplying 3 to all the y coordinates of the green function. So kung 2, 3 siya, magkakaroon tayo ng corresponding point sa 2, 9 dun sa image, which is yung maroon. Mayroon akong point na 4, 2.24, something something. So, times 3 nun, put tayo ng 4, 6 point, should be 72, no? Baka may mga na-cut off lang na digits. But essentially, yung y coordinate natin na times 3. So, all the y coordinates of all the points in our original function, mata times k, in this case, 3, to get our image. Now, if our factor is negative, then mag-i-introduce siya ng additional flipping along the x-axis. And then, if it's less than 1, let's say I'm here using 0.5, yung scaling natin will be a contraction. So, lumiit yung vertical height nung image natin. Although notice, walang nagbago dun sa horizontal length niya. Kasi yung factor, ina-apply lang natin dun sa y coordinates nung points natin. So if I have a point 2, 3 in my original function, if we multiply negative 0.5 dun sa function value, which is 3, then we'll have a corresponding point sa 2, negative 1.5. If we have a point sa 4, 2.24, then we'll have a corresponding point sa image na 4, negative 1.12. Kasi na-multiply ng negative 1/2 yung y coordinates. So I hope that makes sense. Let's move on to horizontal scaling. So let's say we have a function f of x, in this case yung green. I'm using the same name, no? But if I define my image function as f of k times x, so instead of multiplying k sa labas or multiplying k kay x, papalitan natin si x ng k times x. Mag-a-apply siya ng horizontal scaling to f of x, pero yung factor hindi k. It's actually 1 over k. Papaliitin niya. So here, in this example, my k is 2. And let's take a look at the points. Meron akong point sa 0, 3. May corresponding point siya sa 0, 3. Walang nangyari sa y. So tingin tayo sa x coordinates. In my original function, I have a point 2, 2.24. Dun sa image, yung red, na nagko-correspond sa same y value, it's 1, 2.24. Na multiply ng 1/2 yung x coordinate natin na 2, naging 1, para ma-map natin dun sa corresponding point dun sa image. I have 2.5, 1.66. Dun sa image natin, na-map siya sa 1.25, 1.66. And if we take a look at the image, it's essentially kinompress natin yung graph by a factor of 1/2. Kasi ang multiplier natin 2, so ang scaling factor natin horizontally is 1 over k. Check din natin yung mga dulo. From 3, 0, napunta tayo sa 1.50. From negative 3, 0, napunta tayo sa negative 1.50. Yung caveat lang sa example na to ay naka-center tayo sa y-axis. So I want to look at same graph pero naka-translate somewhat to the right. So here is my original function. Nakat na siya. It's the square root of 9 minus the quantity x minus 5 squared. So again, it's a semicircle na naka-center sa 5, 0 with the radius of 3. So medyo nag-zoom in lang tayo. It's the same multiplier. I'm using the multiplier 2. Kung ang radius natin ay 3, tawagin mo natin horizontal radius. Kasi circle siya, so vertical, horizontal radius, pareho lang. But yung horizontal radius natin na 3, dun sa image natin, yung parang horizontal radius niya ay 1.5 na lang. Nag-scale siya horizontally by a factor of 1/2. But what is happening? Essentially, lahat ng x coordinates natin, namumultiply siya nung scaling factor na 1 over k. So yung 5, 3 napunta sa 2.53. Yung 2.5, 1.66, napunta sa 1.25, 1.66. So, hindi natin nakita dito yung nag-scale siya papunta sa gitna. Hindi ganun yung scaling niya. Parang, ang reference pa rin natin ay yung y-axis. So, from 5 pupunta sa 2.5. So, parang yung center of scaling is still, well, hindi siya center, no? But parang, if we can imagine na line, is yung center line, it's still the y-axis. So, naka-reference tayo doon, hindi sa gitna nung original function natin. So, from 2 pupunta sa 1, 2.5 pupunta sa 1.25, 5 pupunta sa 2.5. Kumbaga, ang gitna pa rin natin ay yung y-axis. So, papaganon yung scaling. Hindi yung gitna nung function. And that's it. So, mabilis lang. We just reviewed translations by a vector on functions na nireview natin yung pag-reflect across the y-axis, across the x-axis. And you observe paano mag-scale sa functions vertically and horizontally. Siguro we'll understand this more when we work on some exercises. But definitely, gagamit na tayo ng GeoGebra doon. So, thank you very much and see you sa next lesson natin.